Sekejap Give me some time. I will share the screen. Entire screen. Okay. So if you look at the video already, now you know why we do this this piecewise polynomial, okay? Because last time you learned about the Lagrange, you learned about Newton divided difference. Normally I have like few data only. Okay, let's say I write. It's why. Oh. Okay. Last time, let's say last time you use like Lagrange, Lagrange and also Newton divided difference. You remember PNs, right? So you have, let's say Lagrange, you have to do the weighting functions, right? Start from lepas tu kan ada lagi and so on. And here you kena buat lagi kan, x minus berapa, x0 minus x1 and then so on, kan? Kalau ada berapa n, so you have to multiply a lot. If let's say consider let's say 8 data point. Kalau data point, so you next mean n is 7. So this thing will be 7 times. 1 time, 2 times, 3 times, 4 times. This one many times. And even like you have like L0, L1, L2, L3, L4, that's quite a lot. Okay. So you have to expand this. The equation will be, the formula will be very long, okay? And then so once we have a lot of data points, the accuracy will be reduced. So that's why we have to change the methods. If let's say you have too many data points, so it will be a more accurate and more practical to use this piecewise polynomial interpolation basically. So let's explain pasal spline polynomial. Okay, sebelum kita. So for the piecewise, I got mentions in the video. So last time you use Pnx, right? So for this piecewise polynomial, we will change the formula to S, okay? Sx. Macam ni. Okay, so and now we know we normally use I based on I. Okay, so if let's say we say this is a spline of degree k. So the function, this is a function is actually, let's say this one we say degree of k is function fx, good, x, where this xi plus 1. Okay, this is the interval. Dia punya boundary lah. Boundary, or we can say the interval. Like when we have a graph. Okay, this one I explained extra. What extra from the video? So for those who haven't watched the video, you go back and watch the video, okay? So, kalau let's say we have a graph like this, and then this is the from x. And then let's say this is the x0, and then let's say this is the x. N. Okay, so let's say we have a many point here. So that's why we use this piecewise polynomial where we have to separate into few segments based on the data point. So if let's say we have 8 data points, okay, let's say we have now how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say 9 data points. N is 8. Okay, so n is 8 bit, and how many n here, we can know how many segments that we will have. This one. If let's say we have 9 data points, that means n is 8. So we will have how many s, how many interval, dia punya how to say, the sub polynomial.
Sorry, Doctor.
Let's
7,
say,
7, and
let's say we have 9 data point and n is 8. So now this one I will divide into few sub spline function. So how many spline function I will have? Cubic polynomial. Based on the interval. Based on the interval. Don't know, not understand what I ask. So where here this one, normally we will, kalau if let's say I will refer to this one, saya akan pecah. Now I will separate the whole thing. This one is fx. Now this fx I will divide into few segments based on the data point. So let's say n is 8. So I will have n minus 1 punya sub function. So maksudnya I will have S0, S1, S2, S3, S4, S5, S6, S7. So here I will have another 7 equation here. 1 S0, S1, S2, S3, S4, S5, S6, S7. Right. So I will divide into sub segment or sub how to say sub function lah, a new function, because this one will be have one function, another function, where for the S0 that is when x is from x0 to x1, ataupun kalau in the example in the books, in the video that is right is like this. For x, for this one, for S0, and then S1 should be S1 until X2. If you look at here, X1 here, X1 here. Okay, so dia akan sama dia because it will be continuous at here. So because here, you look at here, if you look at here, S0 and S1, dia akan bertemu, meet each other at this point, at this x1. Let's say this one is x0, x1, x2, x3, and so on. So for example, the equation S2 and X3, S1 and X2, it will meet at this point. Yeah. So this one, you see where this one, they will meet here. Boleh. Okay, go to this one, spline of the degree of K. Okay, so degree, the set of knot, whether it's from X0, X2, from X0, X1, X2 until Xn, is based on the spline degree of K, where, kalau is this one, we'll use this one. Where this is a spline. Where is but the polynomial for this is must be polynomial of degree of K. Kalau lah, let's say, if let's say the K is 1, this is the linear spline. Kalau let's say K equal to 2, ni lah, before this one Lagrange interpolation, we have this one, right? P1 and then P2, depending on the n. Okay, so that means if let's say n is 1, that means that is a linear spline. If let's say n is 2, that means this polynomial is a quadratic spline. If let's say K equal to 3, that means this is a cubic spline. Okay, so if let's say linear is very simple, okay, because it's just like, for example, linear, mungkin like x plus 2. So it's very simple to solve this equation. So we can use this one. If let's say this is a linear, so probably it will more easier. We are using Lagrange or Newton divided difference that you learned before. If let's say this one quadratic, so because this one is how to say, you can also use this Laplace and Newton. I didn't say that cubic we cannot use, but these cubics probably we will be more with, how to say, if let's say the data point is a lot and the polynomial is third degree, that means a cubic spine, so that we can use this piecewise polynomial. Where in this topic we will just discuss on this one lah. Okay. So basically based on the degree of formula. So kalau awak tengok, if you look at the formula, this cubic spine dia akan ada kuasa 3. X will be have like power of 3. Biasanya, if let's say power of 1, that means that is a linear spine. Tapi sekarang now we want to focus, this is a cubic spine. Okay, cubic spine. So go back to the what I got explained in the video regarding this one. I move down. This one. Okay, so if you see this one, the piecewise polynomial interpolations, okay, so we just now I mentioned when we have a lot of data point, we make it more a lower degree of polynomial so that it will more easier for us to solve. So the first and foremost is we want to do, if let's say a cubic using this piecewise polynomial, there's a few criteria that have to be fulfilled. Let's say, given that the functions fx lah, okay, any fx. Here, let's say here, given the function of x, let's say we have a cubic spine interpolations, okay. If let's say you want to do this cubic spine interpolations, cubic spine, we have to fulfill 1, 2, 3, 4, 5. Basically, actually we have 6, but 6 is this one, either that is a natural boundary or clamped boundary. But in your syllabus, we only cover natural boundary. That means this one, the second derivative of x naught is equal to second, as a second derivative of s when x is x naught equal to 0, and second derivative of s when x is xn also equal to 0. So this one you do not cover lah. So basically we just this one, consider this one. So when we want to check, basically we have 6 criteria here. Okay, the first criteria is said that Sx is a cubic polynomial denoted by Six on the subinterval xi plus 1 for each I equal to 0, 1, and until n minus 1. Okay, like just now I asked Zhing, let's say we have a graph like this, right? Let's say we have a graph like this. And we have, let's say we have the, okay, macam ni. Okay, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Just now we have 9 data point. 9 data point, that means n is at n is 8. Okay, so the whole this one, the whole thing, this one, this is a Sx. Okay, this one. Okay, when we have a Sx here, so we will have to, now I will separate it into few segments like this, right? I mentioned based on this point. Okay, so this will be S0, S1, S2, S3, S4, S5. Hilang ke mana satu? Titik. 1, 2, 3, 4, 5, 6, 7, 8, 9. S0, S1, S2, S3. x4, oh, sitting here. This is x4, x5, 6, and 7 here. So that means I will have this one. Total from S0, X, sampai lah S7, X. This one. So mean by this one. So it will be the based on the sub-interval. Sub-interval mean here. Let's say this is a X0. This is a X1. This is a X2, X3, X4, and then continue. This is a X sampai lah XN. This one XN. So here, this one will be from the interval X0 sampai lah X1 until X1. So if let's say S1, X will be from X1 until, X2. So here, this one will be the last one. Let's say Sn will be from Xn minus 1 until Xn. Dia punya interval. So this means this one from here to here is for this equation. Okay. So this is the first criteria. The second criteria is said that as xi equal to f xi. If let's say, for example, let's say I have a data point with a value. Let's say this point. Let's say this point x0, let's say this is 2. And this is a 5, let's say. So this is fxi. That means this one. So when I put the equation, let's say I put the equation as not x here, I put the value of x, that means 2. I put 2 inside. So when I substitute the value of 2 inside this formula, this have to be equal to 5. That means equal to fxi. Boleh faham tak? Can you understand what I mean? Boleh faham tak? Semua diam. Ahmed, are you understand, Ahmed?
Yes, doctor. So far.
Okay. Okay, now, this one you understand, right? So that means the spline function pass through all the nodes. Okay. If let's say S1 X, if let's say I only can substitute, I substitute X1. So when I substitute X1, let's say this one, so the value have to be equal to this value. This is the fx1. Okay, so the third criteria is for spline functions are continuous functions. That means it's connected. Between this one, this spline function as not function have to be connect with the S1. So that means that is a continuous functions. So if look at here, it said that as tak nampak tak jelas, I write it back. Okay, so here it said that this one. So this one is as I plus 1 for I plus 1 have to be equal with f as I xi plus 1. You look at this one. This one will be the same. So, but this one is where these two functions will be connect with this I plus 1. So the example that I can give is this one. At this point, let's say this one is x1. So at this point, we'll have x0 and x1. It continues. So if let's say I want to do I want to, this one should be the same. S1 for the x1 have to be same with S0, x1. Because they are continuous. Okay, between this and this one. Okay, go to the criteria number 4, this one. It says that the spline function are smooth and no sharp corner or its lobes are continuous. That means the first derivative of si plus 1 for xi plus 1 have to be equal with the first derivative of S1, Si x plus 1. Contoh ni saya tulis balik here because that is very small. So for this one is a S prime for I plus 1. For x I plus 1 have to be equal with the S prime for I x I plus 1. Kalau let's say I use the same example again, this x1 and between the S0 and S1. So that means this will be S1 prime, so first derivative of x1. This is x1 equal to S0 prime, first derivative of S0 for x1 have to be same. When it is same, that means that there is a no sharp corner, because if you look at here, this is point, this just now macam mana dia punya point, sorry, the point is like this. This point like this, right? This is x0, x1, x2, and just now the graph, we want the graph like this. So this one we don't want is a point like this. So if let's say the graph are smooth, that means when we do the first derivative of this S1 and this is S0, we do Bezel sekali, first derivative of these two, so it have to be equal. Equal, that means this is a continuous, smooth, the function is very smooth and continuous. So the fourth, boleh ke? Fourth criteria here, when we need the curvature function is continuous. Just now is we don't want sharp, this one, we want it's become smooth. And now we want to make sure it's connect between each other, is connect. Okay? Just now we make sure this one we don't want, we only want to have a curve. But now the fifth criteria, that means these have to be connected. Okay? So when refer to this one, it said that as second derivative of si plus 1 for xi plus 1 have to be equal with the second derivative of x plus 1 xi plus 1 macam ni. Okay. So maksudnya when we do just now S0, we do the first derivative of x0, kalaulah sama with this first derivative of S1, that means this one is the no sharp punya corner, no sharp corner. If let's say we do a second derivative and then we equal to these two, that means that is a continuous. This curve is continuous. Okay, and the last one is the first as not and the last as n. Okay, when we do the second derivative, it should have to be equal to 0. This one, second derivative of x0, that means x ni lah yang first, and ini equal to second derivative of xn, that means not sure lah, normally this one is n minus 1 lah. Okay, sebab based on this one, if let's say we n is 8, that means the last one will be n minus 1 as 7. So as 7, this one have to be equal to 0. So that means if let's say this one is equal to 0, this is a natural cubic spline. Okay. Boleh? Nadia, okay or no, Nadia? Are you okay? Boleh ke? I not remember to record. Wait, let I record. I just remember to record. Now only remember to record. Okay, let's do so I said in the video I already do the example 4.9, and then other than 4.9 we don't have any example. So I will try to look at try to do the exercise. Kejap saya tengok yang mana yang special. Okay. Do I forgot to copy this one. When I take a new page. If you have book, you can turn to page. Let's try turn to page 108, exercise 4, example 20, question number 22. Okay, alamak. Page 108, this is the exercise tadi apa lah, exercise 4, question 22. Okay, so I write the questions there because some of you may not have book. So it said that a natural cubic spine S is defined by S x equal to if one I bring this one. Tak boleh gerak. Entah lah macam mana. I write here that this is as interpolate the data 1 1 2 1 and 3 0 find B and D. Macam mana ni nak buat? Do you have idea how to do this one? Unknown. We have unknown A, B, D. Tak ada C And now we have to find what is B, what is D. Tak perlu cari. How we are going to do this one? Okay, the question is a natural cubic spine. So this one is a natural cubic spine. Apa dah natural cubic spine? Dia punya criteria. What is the criteria of natural cubic spine? Not Soleha. No Soleha, agak-agaknya apa natural cubic spine punya criteria? Tak, jawab. Shukri boleh jawab. Shukri, can you help her No Soleha answer or not? Muhammad Shukri Jalal. Shukri, ada tak? Muhammad Shukri. Fatimah kata S naught S1 is equal to 0. 0 is correct, but maybe you cannot write. Okay, this is a natural cubic spline. So remember, natural cubic spline tadi yang last punya criteria. The criteria yang saya kata, the second derivative of x naught equal to 0. Lepas tu second derivative for xn. Yeah, in this one is n minus 1. Okay, is equal to 0. Kalau sini, we only have 2. Okay, we only have 2. So 2, S0 and S1. And you look at here, we have how many data points? 1, 2, 3. Okay, 3 data points. Kalau ikutnya, we have 3 data points. That means n is 2. Okay, so we only have the functions S0, S1 because until 1 tu adalah n minus 1. Okay, so here, this one. So that means, ini sepatutnya S0. Here, because this is a natural cubic spline, so that means S0, second derivative of S0 for x, when we substitute the value of x0, have to be equal to second derivative of x1 and x. Look at here. And is now we have 2. Sebab kita ada here kan diberi, this is x0. We assume this is x1, this is x2. Boleh faham? And this one is f x0, and this one is f x1, this one is f x2. Boleh tak? Boleh faham? So here is equal to 0. This is a natural cubic spline punya. Itulah. So kalau lah, okay, let's say it say that this is a natural cubic spline, so that means this one, second derivative, have to be equal to 0. Okay, tapi ini bukan first criteria kan? Okay, doesn't matter. Since we already set this one, kita terus buat yang ini tak apa. Okay, now we have to do second derivative from this one. Let's say this one as not equal to as not x. A plus B. If let's say I want to do first derivative, sama-sama can we do with me? Mungkin saya dah lupa macam mana nak buat first derivative. Okay, so this one 1, so don't have lah 0, right? Okay, B and x minus 1. Kalau saya kembang, let's say this one, I expand it, it will become bx minus b, right? Right. So yang cuma yang ada x saja saya akan bezakan, right? I will do the derivative based on the x, okay? So here this one will become b only. And then, yang ni macam mana yang ni? This one, how? How? Faisal, Izani, still remember or not? Faisal. Nak beza macam mana ini? Remember or not? Faisal. Senyap je. Faisal, are you here, Faisal? Faisal? Yes? Faisal? Kenapa? Tak nak jawab? Yes, are you here? Faisal Izani? Faisal? Tak nak jawab. Okay, so if we want, Faisal, are you sleeping? Okay, start with this one. We look at inside. Inside we got x, right? Okay, and we do the derivative. Kita beza x dalam tu, dapat 1 kan? Okay, so saya akan salin balik. Okay, now D. Beza dalam x tu dapat 1. And now here, we got this one. Then we will bring into front. Okay, and then now x minus 1, this one become 2. Macam ni kan beza, betul? Correct me, I'm wrong. Faris, is it correct or not?
Correct.
Okay, so now kita punya S prime naught is B minus 3D X minus 1 square lah kan. Okay, now second derivative pula. So, sini B dah tak ada X, so we no need to do. So now we just consider this one because this one got X, right? So like I mentioned just now, negative 3D, and then we have to multiply with 2 and multiply with 1 inside here, okay? X minus 1, and yang ni kuasa 2, now it's become 1. So that means we have 6, negative 6D, X minus 1. If I'm wrong, let me know. Alif Ashraf, betul tak? Ini correct or not? Alif Ashraf, betul tak? Saya punya pengen. Now I want to do, okay, so now this one have to be equal to 0, okay? Okay, sekarang no. Saya buat yang ni dulu boleh. I do this one. Second derivative of the S1. Okay, so start with the just now S1. Sorry, S1 dulu. S1x equal to A plus B x minus 2 minus 3 over 4x minus 2 square plus D x minus 2 power of 3. Now, I want to do the first derivative. So, ini tak perlu. So, this one only B minus this one times with 1 times with 2 and then x minus 2 plus 3 being in front and then times with 1, the x inside, x minus 2 now become 2. Betul? B minus now is 3 over 2, x minus 2 plus this one 3D x minus 2 power of 2. Haziq, okay? Are you okay, Haziq? Haziq, are you okay? Semua okay ke? Semua okay? Tipo, are you okay? Correct or not, Tipo? Hey, if let's say I'm wrong, let me know, Let me know, okay. Okay, now we do the second derivative of S1. B, we no need to do because there is no X there. Negative 3 over 2X. Okay, satu saya dah tak buat lah. Plus, now is 3 times 2D times with X minus 2. That means 3 over 2x plus with 6d x minus 2. Yang ni adalah ni. Okay, based on just now, because this is a natural cubic spline. So that means S double prime x have to be equal to 0. So that means negative 6d x minus 1 equal to 0 when we put x naught. Yes?
Itu bukan negative 3 over 2 only.
Which one?
S double prime x S1. The
Oh, yes, correct. Don't have this one. Betul. This is 1. Yes, correct. Thank you very much. Thank you very much. Okay, this one is 1. Yes, correct already. There is no x there. Okay, now this one have to equal to 0. So kita sekarang cari ni. Gantikan x naught. What is x naught? Just now, x naught is 1. Okay, x naught. Yang ni pun x naught lah, boleh nampak ni. This is, so basically, the first one is x naught, the last one is xn. So, and here, n is 2. This is x2 lah. So, this will be x1. So, here also x1 is the same. So x naught is 1. Now we substitute the value of x naught. That means 1. So that means 1 minus 1. Go to kosong. D pun tak buat apa. So sekarang saya buat sebelah sini pula. Boleh cari D ya? Sebab dah ganti, dah hapuskan semua D. Okay, now here. S double prime. This one is xn, x2. Okay, equal to 6D. Okay, x2 is 3, right? X2 is 3, this one. 3 minus 2 Ini kan equal to 0. So kalau tengok sini, we have negative over 2 plus with this one 6D. So 6D equal to 3 over 2. D equal to 3 over 12. 3 over 12, 1 over 4. 1 over 4 ataupun 0.25. Okay. Now dapat D. Now we get D. Now next step we have to find D. Right? Just now the question just now asked us to find D. So go back to the criteria just now. Remember, first and foremost, saya rasa tak perlu buat yang first, because first that mean we have to show that fx and then we have a subsection ini. Okay, the first criteria no need, because maksudnya fx will have yang ni lah, as not x, and then this is a x1x. So the first criteria we no need to find lah. And then I think we can find based on the the second criteria. It said that the spline function is continuous functions. What mean that? Let's say here, right? Remember, when this is continuous base, mean these two continuous and based on this. When we substitute the value of x here with x1, both x1, so have to be equal. Same, that's mean here. Daripada sini, as not, kita gantikan x1, we have to equal with, kita gantikan x1, x1. Okay, so as not, punya function is apa ya? Satu aja. So 1 plus b x1 minus d x1 minus 1 power of 3 have to be equal with s1 is a plus b x1 minus 2 minus 3 over 4 x1 minus 2 power of 2 d x1 minus 2 power of 3. So just now the x1 is 2. Betul kan? 2. Look back sorry Okay, yes, x1 is 2 kat sini Kan ni 2. So saya letak sini b 2 minus 1 d 2 minus 1 power of 3 equal to a plus b 2 minus 2, 3 over 4, 2 minus 2, d 2 minus 2, power of 3. Kalau tengok sini, saya dah 0. This one becomes 0, so no need to calculate already. So over here, only got here, a plus with b minus with 2 minus 1, 1. 1 power of 3, 1, d. And then equal to a. Macam ni. So now is, kalau saya gantikan, a minus b plus d equal to 1. So sekarang we have two unknown, we cannot solve because we only know d, we don't know a and b. Okay, so this is one equation we cannot solve yet because we don't have the value. Okay, so apa lagi? Since now, okay, it's very simple when we have a data point is given like this. So that's mean kalau lah, okay, go back to just now. I think yang mana criteria number berapa? Saya sorry, this is the criteria number 3 already. If look at this one, maybe I show to you again just now. This one Ini ke? Oh my god. Try again. Where should I go? Habis kali ni. Wait This one, luckily I put here. Ini yang ni. Oh, silap. Criteria number 2 is another one. This one just now is criteria number 3 already. Okay. Criteria number 2. Okay, now is the SXI equal to FXI. Okay, we can do this one first. Doesn't matter lah. I already go to this one. So now we go back to the second criteria. Spline function passing through all the nodes here. Yang ni. So kita gantikan, we just substitute the value of x. So make sure, if let's say this one is x naught, make sure it's equal to f x naught. So go back to, macam mana ni? Habislah kali ni. Aduh. I write here, but do you still remember just now the equation? Boleh ke saya tulis sini I'm sorry, part tak boleh buka macam mana, I don't know. So go to this one home. Can it? Oh my god. All gone. Aduh. So, ayo. Never mind lah. Okay, this one, okay? So, draw. So we go to the criteria number 2. This one, criteria number 2. This one. It said that the spline function passing through all nodes. Which? That means as I okay, I remember just now the questions we have got point just now. We got 1, 1. Okay, data point. Okay, and then we have 2, 1. Now we have 3, 0. So this one is based on the S0. This one based on S1. And this one you can check either S1 or S0 or S1 because it was continue at this point, X1, right? So start from this one, S0, saya got X0 here, equal to A plus B X0 minus 1 minus D X0 minus 1 power of 3. So the value of F, this one, F X1 is this one. So that means 1 equal to, so sekarang saya nak gantikan, I need to substitute the value of X0 here. Okay, so this means here 1 plus B 1 minus 1 D 1 minus 1 power of 3. So ini hapus, ini 1 equal to 1. Okay, so ini tak ada apa, we cannot solve. Okay, now go to this one. As not when X1 1 plus B X1 minus 1 D X1 minus 1 power of 3. So yang ni dia punya value of Y is this one, 1. 1 equal to 1 plus B. Okay, X1 here, now X1 is 2. Okay, now X1 is 2. Kenapa tak keluar? Okay, so this one is 2 minus 1 D 2 minus 1 power of 3. So kat sini we already have 1 plus 2 minus 1 1 B minus 2 minus 1 1 power of 3 1 times with D. Okay, so sekarang kita dah ada, we have B minus D equal to 0. Kan? So that means B equal to D. Just now we already get the value of D, right? Just now D is 1 over 4, right? So now B is also 1 over 4. 0.25 lah, that means. Boleh tak? Let's check the answer. Boleh tak? Let's check the answer. I check the answer first. Correct.
Correct, Doctor.
0.25. So both are 0. B equal to D equal to 0.25. So get I mean, okay. If let's say more unknowns, so maybe you have to check maybe based on all the criteria. Now because now we only have 2 unknown, B and D. We have to check these 2. So maybe you have to go for the based on this one first criteria. If still got unknown, so you have to go the second criteria and so on. But since if let's say this is the natural cubic spine. That's why normally we will check this one. You can check this one first, or maybe you can go through from the second. Kenapa jadi macam ni pula? Kenapa macam ni? Just now okay, now it's a bit blur like this. So okay or not? So maybe you can try to do other example lah. But because in the here I didn't see another example is already like that is a clamp cubic spine already. Clamp cubic spine. Yang satu lagi 25, 26. Yang similar yang ni tak ada sebab I just found this one only one when there is a unknown something like that. Okay. Boleh? So I think I stop here first for this today class, and I will continue with the natural cubic spine. I think after Raya lah kan? Semua masih semua dah holiday mode. Already holiday mode, right? So class, any question or not? This one. Ada yang tak faham ah? Macam mana, how we get this one? Oh, okay. Are you understand? So if okay, then it's like okay. Semua okay. Doktor, tak ada, memang tak ada value. Ada, tapi saya tak cari sebab soalan tak tanya. If let's say question asks what is A, then I will continue to solve A. Now the question didn't ask what is the A, so I didn't solve A. Yes, if let's say the question got asked A, so you have to do based on others, because just now I only do until X1, right? So next step, if let's say you still want to find A, so probably you have to do the S1 when we substitute the value of X with the X2. Boleh ya Fatimah? So yelah, sebab soalan kan tanya saya dua tu, so saya jawab soalan sajalah, tak perlu buat the rest. If let's say few unknowns, let's say got A, B, C, D kan, let's say, and then ask you to solve A, B, C, D. So probably we have to go through all the criteria. So because now only got two only B and D, so dah jumpa tu okay lah. Okay. So all others okay. So I stop the class today first, and then next class after Raya, I will continue with the natural cubic spine punya procedure, how to solve the interpolation using a natural cubic spine. Yang tadi itu cuma dia punya intro saja. Just now just the intro, okay?
Doktor.
Yes.
Boleh tengok balik tak yang tadi tu?
Okay. Cuma the last part. The front part already.
Yeah. I want to see that.
I show you back. Sorry. I don't know what happened with this window. Always like this. So which one you want to see?
The S naught X naught is equal to 1 because the given point.
Given in the questions, given it said that this function is passing through these 3 points. This one, this one, this one. And based on the equations, if you look at the equation, just now the S naught is got right the formula right, and then if it said that if 1x and then this one equal to blah blah blah, if 2 smaller or equal to 2 and bigger or small equal to 2 and small or equal to 3. So either based on this one, I also can justify already. This should be X naught, the first one, okay? And this is a X1. So this one also X1. So this is X2. So in the questions, they give you the value of f x naught, f x1, f x2. So this is given. So I just check. So the next step, let's say I want to check. So the next step, I can check this one. So that means I can check S1, X2 equal to sama dengan kosong lah. This value. Because this value is Fx2. This one. So masukkan equation tu. So kalau equation itu adalah A, B, D. So if let's say you want to find Fatimah, Fatimah nak cari A, so you go to this S1 equations. So you already know B, you already know D, so you can get A. Okay or not?
Okay, thank you, Doctor.
Okay.
Macam mana, Doktor?
Apa? Okay. Tadi kan awak tanya kat mana A. So saya pergi next page. Insert page. Sekejap Okay. So kat sini kan now I only calculate S0. Then substitute X0, X1, right? So the next step yang ni saya boleh gantikan this one X1 in the S1 punya equation like this. Yeah. So I can this one S1 S1 wait S1 kat tolong. So X1 jap why like this wait saya nak gantikan ayo I cannot write wait sekejap. Oh, what is the mean? Saya tutup muka sendirilah. So funny I feel suddenly. This one kenapa sebab dia ada cursor. Yang ni saya nak cuba gantikan X1 dia. Formula this one formula I'll just write down the formula just now. This is X1 minus 2 3 over 4 X1 minus 2 power of 2 plus with D X minus 2 power of 3. So now X1 tadi apalah? X1 is 2. So yang ni dia punya nilai adalah 1 kan, Y dia 1, Y dia sini. Ni, this one right. Dah tak nampak apa-apa lah. So now A plus B, ini 2, tolak 2 kan. 2 minus 2 plus D, 2 minus 2 power. So here already 0, 0, 0. So A equal to 1. Fatimah, you get ready. A equal to 1.
Okay, Doktor. Faham.
Now, boleh? Okay. So dah tak perlu solve lah. Kalau nak cari, let's say still got other unknown. So you can do this one. Substitute the value of X2 pula. So that means someone need these equations. So X2 is 3, right? 3 minus 2, 3 over 4, 3 minus 2 power of 2 plus D, 3 minus 2 power of 3. Where the F0, right? Fx, yes. So that means equal to 0. So this is equal to 0. So check. Kat sini. Okay, boleh?
Boleh.
Tadi yang siapa tanya, saya pun tak ingat. Just now who already I stop sharing. Stop presenting. Okay? Jasmine, when you come in, Jasmine. Yes, when you come in.
Yep.
When you come in.
5 o'clock.
Okay.
5.
Okay, so I think I end the class today until here only because I got another banker at 9. Okay, so see you after Raya. So selamat Hari Raya. saya nak ucapkan kepada semua, and I hope that this time Raya will be more meaningful to all of you. So after COVID yang lama yang tak dapat Raya, so for those who celebrate Raya, Selamat Raya. For those who didn't celebrate, so happy holiday. So see you again after Raya. Okay? So I end the class today here. So we continue after Raya. Selamat
Okay,
Raya.
thank you.
So you will